Hello and welcome to AP Statistics Hypothesis Testing 101. Yes, I'm aware this is an extremely cheesy cliche, but we had neither the time nor creativity to make up our own catchy title, which you'll only experience for these first insignificant 15 seconds anyway. Without further ado, let's go ahead and get started by first addressing what the frequency is a hypothesis test. And of course, I'm going to tell you. What, did you expect me to ask a hypothetical question in an instructional video? Whoa! In basic terms, a hypothesis is a proposed model by which we analyze data and evidence. The purpose of a hypothesis test is to determine whether or not the proposed model is consistent with that data and evidence. This does not mean that we can prove a hypothesis to be true, however. That's impossible. All we can do is see whether or not there is evidence enough to disprove it. For example, in a courtroom, the jury starts off with the hypothesis of assumed innocence. They keep that hypothesis until evidence is shown that can disprove it. The same goes for statistics. Here, we have a word problem. Terrifying. But all we have to do is break this down into what we need and what's useless. As a general rule, 75% of everything presented in one of these lengthy problems is intended to screw with your mind and distract you, and their only real purpose comes much later in the problem. So try to look for AP stat words like mean, proportion, standard deviation, etc., as well as numbers and what they represent. From this problem we can take out that 60%, which in context represents the population proportion, as it says, all students, as well as the 65%, which is the sample proportion of her 54 students, which can also be taken out. So now we have all the numbers that we need, but what kind of hypothesis test are we going to conduct? Yes, there are different breeds of this monstrosity. Step 1. What are we dealing with? Means or proportions? Seeing as how nothing is mentioned as to an average of any kind, it would logically follow that we're dealing with proportions. Oh, hey, look at that. Step 2. How many sample groups are there? Keyword sample. Populations don't matter in this situation. Kind of like pop culture and society. Seeing as how we only have but a single sample and we're dealing with proportions, we will be running a one-proportion z-test in which we'll ultimately find the z-score of the sample in reference to what's known as our null hypothesis. Remember, a hypothesis is the proposed model which we are assuming is true until it can be disproved. So, the null hypothesis is the model we'll assume to be true, which in this case is the population proportion of 60%, and we will try to disprove this model by using an alternate hypothesis, which we're trying to prove is a better fit for the data we have. However, this is where some of those words mentioned in the problem come in handy. What the teacher is trying to prove is that her school is different, which means we're simply looking for an alternate which is not equal to 60%. If it were to have asked if she could claim her school performs better, we'd only use greater than and focus on the right side of the normal curve, and the opposite from performing worse, we'd use less than and focus on the left side. But since we're using not equal to, we must pay attention to both sides of the curve. Otherwise, if we were looking for an alternate that was greater, but our sample proportion was less than the population proportion, we could automatically conclude that the null fits better without having to do anything. So how do we go about testing this? Well, first we have to assure ourselves of some things to make sure we can even begin the test. These things are known as assumptions. First, we must make sure that the sample was chosen randomly. In this case, the problem itself doesn't directly state that it was random. However, seeing as how this was taken from all of her students, this assumption's purpose is basically fulfilled. Second, we have to make sure that each sample subject is independent of every other sample subject, meaning they can't influence the outcomes of each other. However, if there is a logical possibility that, say, student A possibly distracted student B when lessons were had, thus causing student B to score lower on the exam, be sure to state your concerns, but then move on, because in this sample, student performance on the exam is generally independent, so minor examples such as this would be few and far between. The third assumption to be made is also dependent upon logic. In order to carry out this test, we must make sure the sample size is less than 10% of the total population. Generally, one can make a logical assumption in this situation, as with our problem. We can logically conclude that 10% of the total population of AP Stat students is far greater than 54. Or in simpler terms, the population itself is greater than 540, as 10% of 540 is 54, our sample size. The fourth and final assumption to be fulfilled is that of checking whether or not the sample is large enough for there to be at least 10 successes and 10 failures in context of the problem. In this case, 65% times our sample size of 54 yields 35.1 successes, which is greater than 10. Now our failure proportion is simply 1 minus our success proportion of 65%, which gives us 35%. Multiply this by our sample size of 54, and we get 18.9, which is also greater than 10. So this assumption is also fulfilled. So with all of our assumptions met, we can now transfer all of our data onto the normal model based upon our null hypothesis with a mean of 60%. So basically what we're trying to do by this hypothesis test is find the probability of getting the sample proportion that we did, assuming that the null hypothesis is true. If the probability is substantially low, then we will reject the null hypothesis and conclude that there is substantial evidence that it's wrong. If it's within a reasonable range of the mean, however, we will fail to reject the null and say that there is not enough evidence to suggest the data do not fit within this assumed model. Remember though, never accept the null. You can fail to reject, but never accept the hoe. Kind of like how a defendant is always determined as not guilty, never as innocent, and I'm sure we can all think of a choice example of this being true. If perchance one or many of these assumptions are not satisfied, you will be unable to continue with the test. But before you state that you cannot proceed due to the failure of the satisfaction of the assumptions, think about them once again, and if you're sure, make your statement and end the test. Now here comes the math behind it all. First things first, we need to find out our standard error, which is, for the sake of brevity, basically the same thing as a standard deviation. The formula goes as follows. Since this is a one proportion z-test, we'll multiply the p of the null, which is 60%, and its complement, 40%, which gives us 0.24. We then divide this by our sample size of 54, which gives us 0.0044. Finally, we take this value and take the square root of it, which gives us a final standard error of 0.067. So the formula overall is the square root of p null q null over sample size n. Now that we have our standard error, we can use all of our information and plug it into our z-score formula, which is sample proportion minus the mean divided by standard error, which gives us a z-score of 0.746. Finally, we use this z-score to obtain a p-value, which is basically the probability that the sample proportion we have would be obtained given that the null is assumed to be true. When we plug the z-score obtained in the normal model z-chart, we find a p-value of 0.7734. However, this p-value is set up for less than alternative hypotheses, so we must use its complement. 1 minus 0.7734 gives us an actual p-value of 0.2266, or 22.66%. What this means is that there is a 22.66% chance that at least 65% of a sample population of students would have gotten a 3 or higher on the national exam. Lastly, since we now have all the information we need, we draw a conclusion based upon it in which we will either reject or fail to reject the null hypothesis. In this problem, since a p-value of 0.2266 was obtained, there is not significant evidence to suggest that the AP Stat students at this school perform any differently than all schools do nationally. Therefore, we will fail to reject the null. And there you have it, hypothesis testing basics outlined and clear-cut. Be aware that there are other types of tests as well, but the format is almost exactly the same, save for a few changes here and there as to which statistics are used where.